So first of all, thank you very much for inviting me to this very interesting conference. I have to apologize immediately because my presentation will be a little bit longer than 15 minutes because I understood it was about 20 minutes the maximum. I will do my best to stay within the 15 minutes, but Peter, please stop me if you think that I'm talking too much. Okay. So in recent decades, archaeological sites and monuments around the world have experienced a sharp increase of damage caused by multiple factors, including the construction of large-scale infrastructures such as dams. Their negative impact is becoming more apparent, especially in those countries affected by internal or external conflicts, and awareness on this issue is increasing worldwide. In this paper, together with my colleague Deodato Tapete from the Italian Space Agency, we build on previous paradigms and recommendations to test possible solutions for documenting and monitoring the impact of dams to cultural heritage in conflict zones from space using specific types of satellite imagery. The construction of dams, of course, has sparked numerous researches, which have mainly focused on population displacement, environmental impact, and geopolitics, and which contributed to improve national and international policies to mitigate this kind of threats. However, the debate regarding threats to cultural heritage caused by dams has still little space in social, political, and scientific agendas. This trend reflects a lack of understanding of the quantitative and qualitative damage, and the few attempts made by the World Commission of Dams, UNESCO, and other recent studies that you can see in this slide are still unsuccessfully raising awareness on this subject. However, it's a big issue. And in fact, nowadays we know that over 50,000 dams and hydraulic infrastructure exists or are under construction worldwide. And this may cause four main types of damage to cultural heritage, which include complete flooding of archaeological sites, partial flooding or slow erosion, total or partial damage caused by dams-related infrastructures, and the fourth is heritage monuments relocation and decontextualization. Recent quantitative analysis reveal that dams may affect from a few dozen up to several thousand archaeological sites, depending on multiple factors. However, despite the massive effects, current counteractions in this regard are spotty and suffer from a lack of coordination at any level. Moreover, mitigation strategies mostly rely upon ground truthing activities and in some cases aerial imagery. Of course, the limits of these strategies are multiple, and they include incomplete research methodology, limited geographic coverage, and low level of details, among others, of course. As a result, the latest research called for the necessity to develop tailor-made action protocols for the documentation of cultural heritage threatened by dams. One of the most comprehensive proposals suggested three phases of actions. The first one, preliminary analysis of the archaeological evidence identified through pre-construction archaeological risk assessment, followed by archaeological activities carried out during the construction of the dam, defined as pre-flooding rescue archaeological program. And the third is an analysis of the final impact of the dam conducted in the frame of the post-flooding archaeological damage assessment. For each of these steps, as you see in the slides, remote sensing and ground truthing activities have been proposed. However, only a few of them have been tested so far. Okay, so the aim of this paper is to show the potential of a multidisciplinary collaboration between a satellite image analyst, my colleague from the Italian Space Agency, and an archaeologist, and an integrated approach, including satellite imagery for assessing the impact of dams on cultural heritage. We explore the potential of this approach, in particular to the first two protocols that I have illustrated before. We believe that the use of satellite imagery represents an established and successful method for continuously monitoring cultural heritage in case of site or area inaccessibility due to conflicts, or even in case of other issues like the recent COVID pandemic, for example. The integrated methodology that we are building in this collaboration relies on both validated methods of archaeological protection, change detection, condition assessment, and time series analysis using different types of satellite imagery, in particular radar and optical. And these methods lead to the generation of maps that are analyzed versus the outcomes of preliminary manual identification of archaeological features conducted by an archaeologist with experience in remote sensing. This would represent the starting point of evidence to be then validated in the field through ground truthing activities when site accessibility is restored. In order to provide the most accurate identification, of course, it is essential to consider two types of variables that can influence the detection of the archaeological site, which are the temporal variable and the environmental variable. And we will see them more in details in a while. A careful analysis of these variables allowed to efficiently tune satellite data collection to meet archaeology-specific needs when conflict and political instability prevent field research. And for our study, we used Cosmos SkyMed synthetic aperture radar images provided by the Italian Space Agency and the optical ones from Sentinel-2 satellite, which is part of the European Space Agency Copernicus fleet. Thanks to the diverse capabilities of these two types of satellite imagery integrated each other, we were able to provide useful data at different scales, from landscape scale to small archaeological features. And we tested the feasibility of this methodology and this type of satellite imagery on two representative case studies, one from Central Africa and the other one from the Middle East. These case studies are particularly important and interesting because here we have current conflicts, political instability, or in many cases limited access to cultural property, which do not allow for continuous and in-depth on-site research. The two case studies, as you can see from these slides, are the large, currently under construction Grand Renaissance Dam in Ethiopia and the small planned dam of Halabia in Syria. The first case study, the Grand Ethiopian Renaissance Dam, also known as GERD, has been built along the Blue Nile River at the border with Sudan, close to some of the region where current fights in the frame of the Ethiopian civil war, in particular with the Oromo Liberation Army, are taking place. The construction of this monumental infrastructure started in 2011 and it was completed in 2020. The impoundment is currently ongoing, and it may take up to 5-6 years, eventually generating a major artificial lake flooding a 190-kilometer long stretch of the Blue Nile. We applied for the two case studies the same selection criteria, including scale, type of terrain, current construction situation, and previous archaeological research. GERD, the first case study, is a large-scale dam characterized by extended forests and limited farmland. The construction of the dam infrastructure has been recently completed, although the impoundment is still ongoing. Moreover, the region is barely unknown, with previous archaeological and ethnoarchaeological investigations conducted only in a small part of the prospective reservoir area. Although the dataset of satellite imagery is discontinuous, the Google Earth time-lapse that you can see in this slide, integrated with other sources, highlight the pre, during, and post-construction phases of GERD, but also triggers some hypotheses about the timing of the filling up process, which is also part of an international dispute. As stressed by numerous scholars, in fact, detailed information about the ongoing dam construction and impoundment are hard to obtain due to the unstable political situation in the country, thus making satellite remote sensing the best solution for overcoming this issue. And here, in order to identify potential archaeological sites and cultural properties, we use Sentinel-2 and Cosmos SkyMet images, integrating archive materials, meaning archive photos already acquired before 2020, and few targeted acquisitions from both dry and humid seasons from 2021. The second case study is the Halabia Dam, which was commissioned by the Syrian government in 2010 to flood a 30-kilometer long stretch of the Middle Euphrates Valley in Syria. However, the construction, as you well know, was stopped following the outbreak of the Syrian civil war. According to the selection criteria, we can say that the Halabia Dam can be considered as a complementary case study compared to GERD, because it's a small-scale dam located in a semi-desert terrain with also some farmland. The construction works have not started yet, while preliminary ecological survey already identified 8 sites. Of course, this survey was conducted before 2010. Now let's move to the results. We will start from GERD, and we can say that the manual identification of possible new archaeological sites to be flooded by the dam provided very interesting insights on the potential of both radar and optical imagery, and of course their application in the 2 protocols that I mentioned at the beginning of this presentation. In the case of GERD, the typical architectural technique, which continued from the early 2nd millennium BC onwards, and the correlation of archaeological and ethnographic evidence led us to target indigenous villages made of circular-shaped wooden dwellings. In this regard, Sentinel-2 false-colored infrared imagery, meaning the one to the left in this slide, taken during the humid season, provided very significant results. Thanks to both the light bluish color, which distinguishes non-vegetative areas from the reddish to pinkish, highly vegetative zone, and the distinctive pattern characterized by single scattered dots indicated the single dwellings, we were able to detect several villages, as you can see in the frame, in the black frames in the A image. Of course, we also try to have some kind of feedback, and as a feedback process, we compare these images with open access Google Earth very high resolution optical imagery taken before the dam construction. And they confirm that the bluish dots visible from Sentinel-2 correspond to the single or at least few neighborhood dwellings. And these places may be considered as a starting point for both archaeologists and ethnographers for conducting their research once the situation will return sufficiently stable. Of course, also Cosmos SkyMet radar imagery played a key role in monitoring, for example, the impoundment of the dam. In fact, while Google Earth data presented at the beginning of this paper suggested a first filling up test at the end of 2019, our analysis showed a flooding already in 2016 upstream of the dam. This event would seriously damage any ongoing excavation or survey activity, thus reducing the time for archaeologists to explore the area. Therefore, this finding becomes relevant for the temporal and aerial planning of the archaeological activities in the dam during the pre-flooding rescue archaeological program protocol. Moreover, by comparing Cosmos SkyMet images taken in May 2021 with early October 2021, we were able to confirm that while the impoundment has officially started, despite the limited available information, most of the prospective reservoir has not been flooded yet, thus leaving high potential risk to surviving archaeological heritage. This condition further justifies the value for an archaeological and ethnographic research to be undertaken, even if the dam is still in operation. I'm going to move to the results of Halabia, and then I will go to the conclusions. So in the case of Halabia Dam, we detected at least 5 new archaeological sites that you can see in from the white arrows. The grayish to brownish colors detected through Sentinel-2 false-colored infrared imagery represented the primary element for distinguishing potential archaeological sites. In particular, we found that the humid season enhances site visibility. Then we have shape, which is the second variable to be considered. We can say that as many archaeological mounds have generally pseudo-circular shapes, at least in the Near East and in many parts of North Africa, these are best appreciated in Sentinel-2 false-colored infrared imagery when the red channel that you can see from the image on the top left is more vivid, meaning in highly vegetative periods. Ancient landscape features may also help to detect potential archaeological sites. In our case, we targeted the abandoned meanders of the Euphrates located close to the main river stream, and we found out that the 75% of the documented sites are in fact placed along or close to its banks. The last feature that's provided clues on the identification of potential archaeological sites is the unusual path or shape of certain modern features like water channel, ploughed fields, or roads. And unexpected bands of roads or artificial waterways, as well as the non-regular shape of cultivated fields, generally occur when they met the slope of an archaeological mound. We also used 2 Cosmos SkyMed images in the case of Halabia with a 1 meter resolution, providing a quantitative map of land change to identify damage to known sites. In the case of Halabia, we observed that despite the harsh consequences of the Syrian civil conflict, the site and the area where the dam infrastructures were planned were barely untouched. So to conclude, this research showed that a multidisciplinary collaboration between a satellite image analyst and an archaeologist using multispectral and radar imagery alongside with state-of-the-art remote sensing tool represent a useful approach for rescue archaeology practice to properly document archaeological sites threatened by dams in countries suffering from internal or external conflicts, as well as political instability. Our hope is that major bodies involved in the construction of dams, such as the World Bank or the International Monetary Fund, will implement this type of remote sensing-based measures in the mitigations of risks to cultural heritage. This is particularly pressing in our opinion, in those countries where similar endeavors are done in time of war or political instability, which may further threaten the conservation of archaeological sites and heritage monuments. Thank you.